Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff.
We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage.
What's going on, everyone? It's Jeran back with another live video for you this evening. Promise it will be far shorter than last night. Just want to show a few things, and that's about it for today. Sorry this started late. I was planning on 7:30, not 7. I also changed the title kind of last minute because I was going to make a claim, and I'm always the one saying don't make claims. But I'm going to hold off on it until I have a little bit more time to investigate it fully, and then I'm going to issue it as a challenge. So if you saw the title, you probably know what the challenge is anyway. But I'm going to look into it just a little bit more. Thank you for joining me this evening. Hello to everyone in the chat. Nice that you could be here. Sorry I'm late again. And also I saw a comment, just wanted to clear it up. I saw somebody say, why do you do the minute and a half at the beginning? And the reason why is because people get an alert when I go live, and I've had people say, hey, it sucks because I get an alert when you go live, but by the time I get there, it's already started. So I just figured by doing that, gives people time to get there if they want. That is that. So what I want to start out with is something I talked about yesterday, and I just wanted to kind of clear it up, and that is in discussion about the circling sun. Now, some people have said that it's been debunked, and so I want to bring up some proofs that it has not been. Let's see here. So you should be looking at my browser now. So I found this really cool site. Let me show you where it is here. Okay. So, and it shouldn't shock you. I mean, it's obvious why, but this site is weather.cs.uit.no. It's from the Arctic University of Norway. This is pretty incredible. They have, you can go to any year, previous year, go back even further. And these are all daily time lapses for every single day of that year. And, you know, this is something they don't have in the South. I'm sure people have seen before. Do I have that up? Is it this one? Yeah. So this is the South Pole webcam page. Much different. The fact that, number one, it starts with the live cameras currently down. You can also see time-lapse movies from the camera. So we'll just jump over there real quick. Here's a time-lapse. Takes a little while for it to... Oh, that was quick. So if you go to, for instance, this is set January through March 2016, and we press play on this. So as I pointed out before, if we can just watch this time here and see that the camera skips. So we'll watch it 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 6, 7, 8, 9, 10, 11. So when we're looking for evidence that the sun circles in Antarctica, you know, you would expect to find 24-hour time lapses. It makes no sense why you would have, you know, half a day time lapse. And if anybody remembers, I actually emailed these guys and tried to talk to them about it, and they just made no sense. They said there's not enough bandwidth to do a full day's time. So, but they have enough to do half day. So I was telling him, well, wouldn't it make more sense if you had 1 month of a complete time lapse than 3 months of half day? But again, they said, oh, it's not in our mission statement to provide those things. So, but there's a definite problem here when you look at the sun going 13, 14, 15, 16, 5, 6, 7, 8. So we never get to see any of these, and it's the same for all these. So you can go to September to December 2012, bring that up. Again, it takes a little while usually. And we'll show you here that it's the same thing. It cuts out dates and times, or not dates, it cuts out times, and only shows you about half the day. And if we're trying to get proof of a circling sun, you know, that's not going to help us, as we both agree that the sun goes by half the day. So that doesn't help much at all. Is this going to come up or what? Okay. But this is much different. Like I said, these are, you know, 3-month-long time lapses that are skipping days, and you're not going to find much better. Here we go. Let's play with this one. So this is September to December 2012, and you might not be able to see it up here, but again, it's 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 8, 9, 10, 11, 22, 23, 1, 2, 3. So again, it's completely skipping over the hours. There's not one complete day in any of these time lapses, which is just a joke. It's like a slap in the face. So that it makes no sense to me. Why would we have not one day complete? But on that site that I was just telling you about, again, just to give that web address, it's weather.cs.uit.no. And so you can go to any of these. So let's go to, let's go to 2017. Maybe we go to June 21st. So you go June 21st, and you can then download you just press the L, and it tells you down here exactly what you are getting. The daily videos, small, medium, large, monthly videos, small, medium, large. So for the monthly, you just go down here, and you can pull up. So we'll also pull up like a December monthly. So I'm going to press large on that one, let that download. So once you have these, I'm going to download another one just to have a few. Let's do, we'll go to a previous year, 2015, and maybe a full month from June, and large. Okay, so those are all downloading, and we'll show you those. So very cool site that they have all these time lapses in complete form. There's no time skipping, which I will show you here in a second. Let me get that going. And let's see here, where are we at? Default. And, okay. Is this the right one? 2009, 6/9, 2017, 6/21. This one. Okay. And let me bring that up for you to see. And that one. And OBS. Yep. Okay. Making sure you can see what I see. There it is. Okay. So this is the webcam footage here. And we'll go ahead and press play on this one. So this, you can see the date down here, 2017, 6/21, which would have been, the height of the northern summer. We should get a 24-hour sun. And it looks, all the webcams are taken from this exact spot, at least the ones I've seen. I've only gone back to 2009. It's hard to find days where you can actually see the sun circling, but you will see plenty of them. It's just not every day can you actually see it. You have to kind of find the right day. And let's see here. So I wanted to also show, okay, what day did that go to? 2017, 6/21. Okay, here's 2017, 6/22. Then we got one after that, 6/23. And we can actually see the sun. Usually, it's pretty high up there. It goes right here if you can see that. There's the sun there. And what you get, and especially on the sunny days when you find the good days, I downloaded 20 of these earlier today. Here's a good sun. You can watch these shadows, come around. You actually see the sun make that full turn. Let's go to 6/23. So, we have something here which is the sun in the north doing a 360-degree turn. Here's the sun here. About your body. You have to do a 360 turn if you're going to watch it. I did another thing today, and I just did it for myself, but also so that anybody can do this if they want. What I did was, hopefully I can find it here. What I did was I just randomly went to, and I'll show you how I did it. If you go to Google Earth, I just randomly went down to Norway, which is, I'm sorry, I didn't go to Norway. I went to Svalbard. And when you go down here, you can find that there's tons of hotels, little eateries, restaurants, car mechanics, tons of businesses. So I said, well, we'll just call businesses and ask them if there's a 24-hour sun. I don't think that it's not like it's directed to the military and they're trying to protect. So I did call, and I have that recorded. Let me just show you that one phone call, just so anybody can do that. It's not a matter of, I did it, so it's proven. Take this, go to any of these locations, call them and ask them a question about the 24-hour sun. They're going to tell you. So let me show you that. Okay, and here we go. Let me get that call up for you. It's a short call. It's like a minute. But that's the kind of thing that I think people can prove. The problem is you can't call somebody in Antarctica. Let me bring this one up. And I don't know where my video went. 1 second. Default. I'm going to have to load it here because I don't have it. Load this one. Okay. Now it's going to come up. So hopefully you can hear this. Let me turn it up. Hello. Do you speak English a little bit?
Yeah.
Okay. Quick question for you. My buddy and I are staying at the hotel in June of this coming, 2018, and we had a bit of a argument. Or I was telling him that we'll be able to see the 24-hour sun, and he said that we will not. Will we be able to see it in June?
Yes, you will. It's here from April until end of 26th of August. I think the sun goes down.
Okay, so that entire time, if we're going June, and I think we're there the 20th through the 24th, then we'll see it from there, right?
Definitely.
Okay, thank you very much.
Definitely.
Appreciate it.
No problem.
Bye-bye.
Bye.
So hopefully you guys heard that. Just as, you could do that yourself. Just call anybody randomly, and they're not going to try and lie. They're going to tell you the truth. She was obviously pointing out that from April through the 26th of August, and if you live there, you know the exact dates, that the sun doesn't set from April through the 26th of August. If that is true, then anyone saying that they have debunked the circling sun is out of their mind. There's nothing left to say. How have you debunked the circling sun when it clearly circles? If you stand, and I'll just show you a little example so we know what we're talking about here. Again, I'm not saying that the AE map is the map of the Earth. I'm saying that there's no reason to treat it as people have, like it's some sort of, you got to get rid of it. It's a Frisbee map. Well, if that's how you think of the Earth, then that's fine. Then, maybe you can get rid of it. But to then start putting threats out and saying, if anybody has this map or if anybody does, it's just ridiculous. We're researching. Nobody has all the answers. It's going to take a while. So this here image, just to kind of show you what we're seeing from Svalbard, which is, up here. Oops, what happened? There we go. So Svalbard up here. So, they're seeing on the circling sun, they're standing here and they're having to twist. They're having to turn 360 degrees around to watch the sun. So I don't get how anybody is saying that they have debunked the circling sun when clearly it circles. The moon does as well. I'll show you that here shortly also. And then if you wanted to see, like from the webcam that we're using, that webcam is from Norway. So it's a little bit more, it's a little bit more here. And it's kind of outside the circle. So there's going to be no day that is 24 hours of darkness. What they're going to see, and again, it works perfectly with this map, which is why I'm kind of bringing it up. If you've got something going on the Tropic of Capricorn, if the sun is going in that path, so, we're going to be doing it here. That's terrible. Wow, that's a bad circle. Let me just do a circle. Be easier. Let's do it that way. Okay, and orange, and off. All right, so if we're getting this kind of path here on the outside, and where does the tropic go? Yeah, there. If you're getting this path, well, then where's the only place that somebody's going to see the sun if they're here? Well, the only place that they're close enough to see it is going to be, in this region here. So they're only going to see the sun rise here, set here, and they don't see it this entire time out here. So that is pretty much what we see from the webcam. Many people have seen pictures of or video of the 24-hour sun where it's kind of doing the one of these in the sky, which is what it would do if you weren't close and you were watching it. So, for instance, when they get close to their summer, which we'll do this here, which is this inner track, maybe there-ish. It's a little bit more out there. So the same thing here is they're going to see the sun for the entire time. Now, they're a little bit outside the circle, like I said. So, again, they're going to lose the sun probably here. They're going to see it rise, come across, and set. And from their view, they're going to see it, since it's rising, it's going to be low in the sky, and then it's going to come up as it hits noon, which is going to be here. So it's going to be at the highest point for them there, and then it's going to go back down and head around this way. then it's going to set, and then come back up with a rise. So it just makes sense on this map. I don't think there's anywhere near any enough problems that we would need to disgrace it. Maybe we can check out in a second Flat Earth Asshole's video to where he's decided to make fun of the glass half dome placed over the azimuthal equidistant map by making jokes about, well, if you live in this glass dome, how do you breathe? And for anybody that dense, how can you help them? Nobody is saying that you live inside of a glass dome. As we've said hundreds of times, the atmosphere of the Earth acts as a lens. So since we can't manufacture a little tiny atmosphere to put on paper to show you on a video, then the glass magnifier works much like a lens. It is a lens. It's a magnifying lens. So what people are showing is how light reacts in that dome. Here's the weird thing about the dome of the Earth, and this is going to sound crazy. I know that, but this is the way that I'm seeing it. At least my research is showing me. The dome, call it a dome if you want, call it an atmospheric effect, whatever, is actually situated that it's the lowest at the poles, okay, and the highest at the equator. So the dome is going to be, and when I say dome, I don't mean like a glass dome, but I'm just talking about the atmosphere, is going to be something like this. But it then has to go like this. And, you know, obviously that would be everywhere. There's going to be, it's basically like a donut with a dent in the middle. And so this acts as its own dome piece here. And the reason you can go off that is the stratospheric heights are the lowest at the poles, highest at the equator. Mid-latitudes, it's more like something like that. Mid-latitudes are in the middle. So this is why when I've said before, when you are down, you know, let's say here and you're watching a sunset, and if the sun is directly east of you, but you are looking up into this kind of curved area here, well, then the sun might be observed there. Even though the sun is actually there, it's just the way that the atmosphere works. It's kind of hard to explain, but one way would be, let me show you if I can make any sense of this. Let's try and go like this. So if you had, okay, if we have a guy that is standing down here, he needs to be other than black. Okay, so we've got a guy standing here, and then we've got a layer of atmosphere above us like this. Let me get some color in there. All right. Okay. So this is the atmospheric layer that sits right above our head. And again, if you've done any kind of study on where the sun is displayed for us, it's very, very close to the Earth. Again, it's, you know, a high altitude balloon is what, 100,000 feet. You know, the sun to me looks to be, I don't know, a few 100,000 feet more, maybe 4 times that height. But let's say that it's 500,000 feet. Let's just say, is an example. 500,000 feet divided by 5280, what is that, about 195, 94, 94.69. So it's about 100 miles, let's say, right? So what is 100 miles on this map here? Well, 100 miles would be, you know, maybe from there to there. You know, you're talking about such a little, now flip that up. That's how high above you the sun is rendering itself. So it's very low. So that's why I drew this atmosphere low here. So if you've got the sun here, we're going to draw a little ball. Okay, so we've got the sun here. Okay, there we go. And it's going to be seen through this atmospheric lens. So, you know, this person here sees the sun right above them. There's no way this can move in any direction. It's right above you. Even if you're looking through the atmosphere, you're seeing the sun where it is. But then if you have this guy here, oops, sorry. So if you've got this guy over here and this guy over here, okay, so each of them is going to see the sun. This person's looking at the sun here, but he's going to be rendering, sorry, this one. So he's going to actually see the sun in his atmosphere here. Just like this guy sees his here in the atmosphere. And then this guy, of course, is going to see his there. So if that's not a good depiction, I apologize. That's kind of... so, the actual sun is here. The apparent sun is here and here. Now, I didn't include all of the facts that we're looking through a dome-like atmosphere. The reason for that is if the least amount of distortion to you is above your head, so you're looking straight up, this is the least amount of distortion, and the heaviest amount of distortion are on the edges, well, that's kind of like a shape like this, where you've got the most amount of atmospheric effects happening on the outsides here when you're looking at a distance. Another way to look at that is, this guy's looking this way, so he's seeing through all this atmosphere here, which is affecting the place of the sun. If you put somebody even further, so this person over here, when they're looking at the sun, they're even looking through more atmosphere. So that's what we mean by when we say a dome. It's just the way the atmosphere would work. And really, each person has their own view circle. I know Morgile and I had talked about it in the past, calling it your own snow globe. Each person's surroundings are contained in their own little snow globe. That's why you get the sun rising in your view and setting in your view. That's all part of the system. That's what you have. You have your own. It's not a simulation. Doesn't mean it's simulated. It means that that's the way the atmosphere and the surroundings work for you, is that each person has their own view circle. You are truly the center of your own universe, if you want to look at it that way. So I wanted to show that. Hopefully that makes sense. And yeah, so again, the hard part to understand is that it's not a dome like people might think. It is not a glass dome that goes over the entire thing. Because we know that the heights of the stratosphere, we know where those things start, and they're very low at the poles, a few thousand feet, like 11,000 feet. And then they get up to about 55,000 feet at the equator, and then go back down at the pole here. So you have to kind of picture like a tunnel, right? And if you picture it that way, then you start to see, and this is just impossible to draw, and I'm a terrible artist anyway, but let's say we've got this kind of atmospheric acting as a dome area here. Okay, so when the sun is in this region here, it can reach certain areas, but maybe not others, because of the atmospheric effects. I don't know. It's probably not the right way to explain it. It can travel further, the light, based on where this sun is. If it's here, you're not going to get light traveling over here, right? And if it's here, you're going to get, this much light covered. So you have to kind of look at it that way as far as, and then when you get to the outside, as we get over here, then it's possible that it's lighting up the entire thing. And again, that's the coffee cup caustic. Again, people can say that's been debunked, or we don't live in a coffee cup. Yeah, no shit. Nobody said we live in a coffee cup. It's a known atmospheric effect. And I'll actually show, let me go back to the browser. Okay, transition over here. And I'll show that again on this ray optics simulation. Again, the website for this is RICKTU 288.github.io. And I'll just show this ray optics. Hopefully you're seeing the same thing. Yeah, okay. And so this is really cool. You can take any of these things, and I challenge people to play with it, because somebody's going to see something that I still haven't seen. You can take any of these things. You can take a mirror. You can take a glass, which would be the atmosphere. You're looking at a lens or other here. So for instance, you can then draw the same lens we just did. So here's our lens or the atmosphere like this. Okay, so now we've got this atmosphere. We can take a point source of light, which like the sun is, okay? You can then change the rays from extended rays, which isn't that interesting? That's the Illuminati symbology, the illuminated ones. You can also see all images or seen by observer. Then you can move your observer position, and this is exactly what I was saying. So you can see here where the sun is rendered for the person who is below the atmosphere. So again, the sun is here above the atmosphere, but this person sees it there. Now, depending on where that person moves, they're going to change the view that they see. That's pretty crazy right here. You know, I was drawing a straight line, kind of doing a simplistic idea. This obviously shows you that it isn't so simplistic because this is rendering here in this atmosphere. And then you can play with this and kind of see what does different shapes do. You can also do, let me delete this out. Oops, this one, delete. And we'll take this one, delete it. So you can also do, there's my observer. You can also do like a lens or other. You draw the first line, and then you can do, I'm trying to hope I remember how to do this. The other way. So you can also play with it like a, there we go. Get yourself a little dome-like atmosphere there. And hopefully I don't screw this up. Come on, back down. Oh, something like that. So now you've got, sorry, it's the best it's going to be. Then you can start moving these pieces around if you wanted to see what different, oops, don't screw that up. There we go. So something like that. And then again, put your point source of light back up here. And you can see that as the sun moves this way or that way, what happens with the atmospheric effects. Again, you would put this person closer. And also you can see how things would rise and set basically with distance. If you pull this more in like this. Oops, why does it keep doing that? This one, move this down. All right, there. So if we do something like that, and then you'll see where, if we put this guy here, then if we can see how the sun is basically setting as the sun travels across the sky. So it's difficult because, again, like I said, the way that I think that the dome is set up like a tunnel, like a indented dome with like a ball stuck in the middle of it, that's going to, cause this to be very difficult. I don't even know how you would model that in this kind of a simulator. You can also do, just for an example, let's delete out this one and delete this one and delete this one. Okay, you can also do circles. Hello? What happened here? Let's go reset. All right, so you can also do the circles. So you can do a glass like this. And this is where you get the coffee cup caustic from. You put this circle here. And then you can take a point source of light. And so you'll see here the coffee cup caustic is this, what we see here. And as you get closer to the outside of your lens, you get a lit up area. Now, this is basic. It doesn't mean, again, you can make fun of it all you want. These are the ways of finding what could possibly be true. And when you see something like this that can explain a circling sun that gets close to the middle, gets close to the outside, again, this is acting as if this whole thing can be lit up by this. We have to then realize, well, the distance would be smaller that it could light up. But as it gets too close to the outside here, it gets picked up by that lens and propagates all the way around. So when we have 24-hour sun in the south, could it just be that we're getting 24-hour light, yet the sun itself is still traveling around, causing the outside to light up? So that's why that's cool. And again, you can do extended rays, which kind of give you a clearer idea of what's going on. Then you get this kind of reflected look all the way around. You can also do all kinds of things. You can put a blocker in. Again, I'm not saying the Earth has a blocker or anything, but if you put a blocker here and then you run there we go. And then you run a point source of light here. Now you've got part of it being blocked by this blocker, especially if we go rays. There we go. So that's a little bit easier to see that now you can kind of picture something. Again, I'm not saying that's the case. It could be anything. I don't know that answer at all. So you can also do, a ruler if you needed to use a ruler to get your distances down. You can use a protractor if you want to get your angles down. So there's lots to do on this site. Again, it's Rick, RICKTU 288 github.io. We'll delete that. The other things they have, you can do a mirror, which just gets crazy. I also like the beam. So you get a beam of light here. Now I can spin this beam around. So you can really get creative. For instance, let me just do this. If we had I'm just doing this off the top of my head. So we've got a lens here, and we're going to just make it like this and across. Okay. So we've got a lens like that, and let's say that there's some sort of mirror. You know, it's an interesting topic, the fact that you can't make a rainbow indoors without a mirror. And yet outside we can make rainbows, or we see rainbows, and there is no mirror. So, you know, what is it that's taking the place of the mirror? But if we kind of just play with a mirror and go circular arc, I believe. So now I can take a mirror and I'm going to put it up above this thing here. Okay, so now we've got a mirror up here. And then you can take this beam of light and we can shoot it from here and see things that happen. We can also take it and shoot it from up here down, but you can go extended rays to see them come through. This is interesting too, because one of the things that I've seen, and I tend to think might be the case, is that the sun, excuse me, the sun might actually be the focal point of whatever light is coming from the outside. So for instance, this point here would render the sun, because that's the focal point of, you know, coming through some sort of atmosphere or some sort of lens. We don't know. But there's lots of interesting things to do with this that are very interesting. And again, you can also take this down to all images. Interesting things here too I've been seeing. Where did I go with my light? Oh yeah. So this is, I don't really get what all images mean, but when I circle this, that's too big. When I made a circle like I had earlier, shoot, I don't know how to make a circle. No, it's a little too big. When I made a circle like this and then I did all, let me go reset and glass circle. Okay, so when you have a circle like this, there we go. And we have, say something like a beam or let's see, beam, and we'll do the beam like this. And again, you can just see different things if you were to rotate this. If you do all extended rays, then you get the reflection coming back. And then again, you can also do a point source. Oops, and let me delete this one out. So anyway, there's just lots that you can do in here. And when talking about the coffee cup caustic, which is when you get too close to this outside and everything lights up, and that's a known effect, and I think people have seen me show it before, but if you go to sun arcs, just to look at what they look like, okay, so when we just saw that thing that said all images, this is what they were showing, is these kind of effects. And when you see this, or we see this, and you go to a coffee cup caustic, let's see, we'll go this one. So if I do coffee cup caustic, we'll see that that's exactly the same thing. So go here, go images. All right, so you see this effect that it's happening coming out of this glass. It's happening in this coffee cup. No, it doesn't mean we live in a coffee cup. Anybody who surmises that has lost their mind. But you can see these effects that happen because of it, and it just so happens that we're seeing the same effects in reality. So that should tell us that we need to start looking around the ideas of the lens, of water, of reflection, of refraction. That's what's happening, is you've got the light source on the other side lighting up the entire other portion. You know, the light's on the right here coming through, lighting up this. And when we look at sun arcs, it's the same thing. This is almost to a T, it's identical. Now, they want to tell you some nonsense about this, that it's ice crystals in the sky and that they're at the perfect angle. I mean, it just doesn't make sense. Neither does their explanation of rainbows. Anybody who thinks that they know the reason for rainbows, it's insane. The ideas that they just pass off and people say, yeah, I guess that's true. I guess that rainbows are, you know, light reflecting back and forth off the inside of just these particular raindrops at this particular angle. It's crazy. So just wanted to show that the coffee cup caustic is what's happening. Now, how is it happening? What is causing it to happen? That we don't know, you know, but when you look at this and you go back and look at these, we're seeing the same exact effect. So we need to, here's a simulator, it looks like, showing that here's your point source of light. nephroid caustic in a coffee cup, showing how you get this reflection, but you've got this whole outer area is being lit when the point source of light is here. So, it's not as simple as to say, oh, well, there's 24-hour light in Antarctica. And, I've started looking recently about Antarctica and trying to figure out, do they ever say it's a 24-hour sun? And the more I'm looking, I'm finding them say it's a 24-hour daylight. They may not even claim anymore that the sun does circle your head. It maybe is just a 24-hour daylight, which would be the cause of something like this coffee cup caustic. I did want to show you this, and I'm going to let everybody know this site here called White Desert Antarctica. It gives trips, or not gives trips, offers trips to Antarctica. It says only 300 people a year get to go, or 100 people a year, I think is what it says. So I'm going to start a GoFundMe because I would love to go down there and check it out. So the price of it is real cheap. To go November 28th to December 6th, it's $80,000 per person. So I figure my wife and I will go down there. It's only $160,000. So I'm just going to do a GoFundMe and, appreciate you guys. No, I'm just kidding. Not doing that. That is ridiculous. $80,000 a person. $80,000. It also comes with a Maserati. Nope, doesn't do that either. $32,000 for a 4-night stay. These ones say fully booked. I don't know what kind of people are paying $80,000 per person. $160,000 for you and your wife or you and your girlfriend to go down for 8 nights and check out this place. So, no. And if you didn't understand it, it was a joke. I'm not starting a GoFundMe. I'm not asking for money to go to Antarctica. So, but I did check out this site, and it was somewhere, I don't remember exactly where I saw it, but it was talking about, what you can expect down there. And again, it said that they would cross. Let me see if I can find it exactly. Was it? No, it wasn't waiver. There was a little map that showed, or maybe it wasn't here when I put download brochure. No, I don't think that was it. Let me see. Maybe it will be. Where's that little map? Yeah. Okay, this is it. So one of the weird things I noticed was, first, this flight goes from Cape Town, South Africa, down to Witchaway Camp. You'll see down here it says flight to Antarctica 5.5 hours. Then I thought what was weird is down here it says flight to Emperor Penguins 2.5 hours. Okay, that's this little excursion here. But it says flight to South Pole 7 hours each way. So that's interesting that this flight here, 7 hours each way, this flight here is 5.5 hours. Just interesting. But as we get down here, so I just thought this was interesting here. It's talking about during the 5.5 hour flight, the African night turns to day as we soar over thousands of icebergs and pass into 24 hours of continuous sunshine. So it's just interesting that they don't say, circling sun, 24 hours of sun, it's sunshine. Well, the coffee cup caustic would cause that kind of an atmospheric effect. This here is interesting. Doesn't really look much like the sun, but this is your digs for $80,000 a person. It's pretty gnarly. I guess you get to go see these penguins. So now you can check out this site if you want. It is white-desert.com. They look legit. I can't tell. I've not ordered any. I don't know who's paying that kind of money to go on these trips. But there was something else I was going to show in this, or I don't remember. This is the itinerary. Thought there was something else I wanted to show. Nope, not that. Nope, nothing I can remember here. Please bear in mind, altitude sickness. Nope. Yeah, so this anyway, $80,000 a person. What a total joke. And this just does mention that flight extra time that I was talking about, because it talks about, even though it says we stop for 1 hour to refuel and then continue another 2 hours, well, they say here the first part of the journey is a 5-hour flight to refueling stop. So it does fly 5 hours, stop, and then fly 2 more for a total of 7, when the flight, which is much longer, maybe we can check that out real quick. I didn't do that, so let me see. If we go to Google Earth, let's just check that out real quick on the fly. So if we are going from Cape Town, and we're going to be, where's Cape Town? Right there. So they're going to fly to, I didn't really see where they were going, like here-ish. Let me go check that real quick. That map was up here. Okay, so about there. So, and then so I got 2,500 miles, and then they've got, let's clear that, 2,500 miles. But then from here to the South Pole, 1,300 miles. So you're talking about 1,200 miles further, but you're getting this distance done in 5.5 hours, but you're getting this distance done in 7. I don't know, just seems very interesting, something to look at. And then it showed a 2.5 hour flight, basically going from here to here, which we've got about 668 miles. So just interesting there. Hopefully, I showed you that. I think I did. And we were done with that. All right, we're going back to the browser. Here we go. So the other thing that I saw comments about, just trying to go through my tabs here and make sure, was we've seen the coffee cup caustic. We got that. We got the sun arcs. We saw that. And I've got that up. Oh, so somebody wanted to talk about this. They said I didn't do a good job in the cosmonaut video of explaining where I was, what I was looking at, and because they thought it was a big deal to say none of those mountains should be seen, and yet we see them. So this is Vera Playa in Spain. We can see that we are looks like on a hill. Can't tell how high it is yet, but we'll find that in a second. We're looking out here, so we can go to, and I'm just going to do this on my own. I'll show you the screen in a second, because I'm going to be looking at Google Earth, and then I'll show you. But so Vera Playa, and Vera Playa. Okay, in Spain. There we go. Okay, so and then I'm spinning this camera. I'm just trying to find this exact spot, and then I'll show you so we can agree that we are on the same spot. And it looks like I have a mountain here. So let's straighten this out and see if you agree with us being in the right spot. Okay, so there. All right, and Vera Playa. And what is that? Okay, so let's go back over here. Oops, wrong one. Okay, Vera Playa. So just trying to see if I could tell. Okay, so this little circle turnabout here should be easy to find on Google Earth. Doesn't look like there's another one. Hotels or something. Okay, so that goes that way. This goes this way. Okay, and let me go to Google Earth and make sure I find this little turnabout. There it is. Okay, so now I'll just flip over here so you can see that we are on the same page. Google Earth. Okay, so you can see here that this is the same little circle pattern that we just had over at here. Right, so I'm sure that you agree on that one. And then looking at Google Earth and trying to figure out how high we could be, there's some tall mountains here. I don't see anything elevation-wise much higher than, and we have to get way back here. I'm not getting anything higher than 100 feet. So let's get down here and see. So it looks to me like, let me push this over here so you can see what I'm doing. Okay, so here's this image that you're looking at. So this whole land here, 56 feet, 60, 70. I don't see any 80s yet, 70s. Here's 82. So I don't see anything 100 feet. 66, 77, 55, 56, 49. So, I mean, to me, we could say 100 feet eye height. I don't think the person is way back here, but we'll keep going back here just to see. Now we're at 100 feet. They could be up on this hill, 125, 154. Are they here? Let's see if this looks like what we're seeing. No, there's no way. Then when they turn left, they're going to have this big rock in the way here. But if we go to the browser again, transition, and we spin this way. Okay, so we need to be able to see out past this little nook here. So we'll bring it back. I'm just checking Google Earth again. So no, it forces me to go way back towards the shore, or else I can't have that view. Let's find that circling thing again. And I lost it. Oh, there it is. Okay. Where did you go? There it is. Okay, and if I turn to the left here, I know you can't see what I'm doing. I'm just checking this. Yeah, so let me show you this view again. Google Earth. Transition. Oh, you know what I can do? I'll make this easier on everybody. Let's do them both on the same screen. 1 second. I'm going to try and fix this. This way I don't have to change it back anymore. So we'll get rid of this. Delete. Yes. This one we're going to shrink down a little bit. All right, hopefully this looks decent enough. So I've got that screen, and then I'm going to add the browser screen. Scene, browser. And this way I don't have to keep switching back and forth. And we'll go there. All right, and there. Put this one behind that one. Yeah, something like that. It'll work for now. Up and lock. Okay, so now you can see that there's both the screens, so we can kind of play like this for now. And back to Google Earth. So again, remember this little cutout here looks like the same cutout here. So, you know, it doesn't look to me like we're much higher than 100 feet. Well, we'll call it 100 for now. So if you look off here in the distance, you can see we've got this little inlet here, but then across we've got this rock, hugely prevalent. Looks like a city next to it. So we got this rock. And then whether or not you can see this, I'm not really sure. But behind that rock is a much, much more light, but you can clearly see, you can see the peak here. You can see it comes out here all the way across. We can still see it. We can still see it. I can still see it. There's another peak there. Can still see it. And it looks like it ends right here. Okay, that's where it looks like it ends to me. I don't see any more mountains past this way. So if we said, what is the distance from where we're at to this point here, which we started at this rock and worked our way along the back of the mountains. So we're going to Google Earth. So if you look at this, and I'll ting this, this is when you have the exaggeration, what do they call it? The elevation exaggeration. I have it on 3, but I'm going to turn it down to 1. So what we're looking at from here, here's our circle area, is we're looking at this view, and we're seeing these mountains here, right? We can see, let's get back down here. Sorry, clear. So we can see, again, we were about here, and we can see that big mountain. Let's go this way. So if we come out here, that big rock is right there. Okay, so what we're seeing is this big rock. I'm going to move faster. All right, so here's that big rock. Here's that town that we were seeing next to it. And then from our angle, we're seeing the end of this little mountain range. So if we pull back here and we go draw a line, so we're going to see from the end of this mountain range to where we were down here, which was iffy, I don't remember now. So where's that? Right, that roundabout there. Okay, so we're a little bit behind that. Let's say we're on this hill or whatever. We're seeing about that. So we've got 66.15 miles. Let me write this down. So we got 66.15 miles. We said we're 100 feet. We're going to go here real quick, and let's go here. We'll go to the curvature calculator. So let's say our eye height is 100 feet. Let's give it 150. Who knows? 150. Target distance of 66.15 miles. Calculate that out. So we've got 1,744 feet of hidden. Okay, hidden, obscured by the curvature of the earth. So that means that those mountains better all be taller than 1744, right? So we're going to go back to Google Earth, clear this line. Let's get out here and let's check out how tall these mountains are. Again, this is that rock. So everything we're seeing is to the right of this rock. Okay, so we're going to get up here. We're going to go over here and check out these mountains for heights over here. So as we start passing my mouse through this, we'll see that we've got 100 feet, 160, 300 feet, 700, 800, 1,200, 1,484, 1,736, 1,800, 1,500, 1,200, 1,000, 1500, 1100, 1100, 1300, 14, 15, 15, there's a 16, 1603. So this whole entire range, 1654, 1697, 1700, but I don't see anything over 1700. And we just saw that the curvature of the Earth should be blocking 1,744 feet. That's with an additional 50 feet on the observer's height, which I don't even know where that can come from. There's nothing up that high. And, so what are we seeing? When you look back at the, sorry, I left this place on there. Let me go, where is it at now? Here we go. So when we look out here, clearly we see this rock and then we see these hills. Well, we just said that there's only one or two peaks that even came close to 1,744. So how are we seeing any of this? Any of it. Clearly all of this shouldn't be seen, especially when you get down towards the edge. And again, if people want to believe in refraction, then they're not truly understanding what it entails. Because if what they're saying is true, that because the sun is behind and whatever, it's lifting up things that we see with our eyes and bending light. Well, then it's lifting up the water and it's bending the light of the water to us. So basically, if they're going to talk about refraction, then it defeats their whole argument that things are behind the curvature. You can't have both. You can't say, oh, it's lifting things up, what it knows where the water ends, so it's lifting things up and placing them at the water line. Doesn't make any sense at all. If it's lifting things up and it's curving light, then everything we see is curved. Meaning, if it's lifting up the water, then we're seeing the water higher than it really is. And if we see buildings behind it, then the reason for that is because it's lifted up the water. Therefore, the whole argument of things being behind the curvature because of refraction just doesn't work. There's no way any sun is causing this mountain range to be lifted up. It's an insane belief to think that the sun, because for whatever reason it's bending light. Maybe it's bending the sunlight that we're getting. The atmosphere can do that, but it's not doing anything to those mountains. It's not lifting them up and moving them. Now, I do think it is magnifying them. Okay, I do think there is a layer of atmospheric effects here that is causing this to be magnified, but it can't magnify what's behind the curvature. It's just magnifying what's there. And I've talked about it before, that when you do that, because the very first thing, let's picture here, there's hopefully you're still looking at my screen here. Yeah. If you're picturing here a layer of atmosphere, okay, and it's acting as a lens, well, the first thing that it's magnifying is the water behind that lens. And then the farthest thing would be these mountains. And it would, as I showed in, don't remember the name of the video, plain point number 3, that when you take a magnifying glass down to the surface, that it magnifies what's closest to it, obviously what's right after the magnifying glass, more water, and it can cause items behind that to appear behind the curvature or behind the wall of water. It's all atmospheric effects. Sad thing is, these things are not difficult to really understand. If science just was into the truth, well, then we would know that dinosaurs, were around 40,000 years ago, and all these other things that science has already proven, but that scientism doesn't allow. You can just lose your job if you want to venture down the real road of truth. You will quickly find your job removed and your ass on the streets. So it's just safer to play by the rules and not question authority. But really, we need people to do that. I, by no stretch of the imagination, am smart or should be. There's so many more people, billions of people, 10 times smarter, that if they start looking into these things, they're going to find that we've been lied to. It's that simple. And I know it's difficult for some people and they don't want it to be true. And believe it or not, neither do I. I don't want the earth to be flat because it takes learning a whole new everything. And that sucks because, we sat in school for 13 years where we should have been learning the truth, not being fed, propaganda, which is all that we were taught in school. So this Gigapan is an awesome site to go to. Some of the most amazing views, and you can go. I like to search for things like, search for horizon, or beach horizon. Some of these views, we just need people to recognize the distances that we're seeing. Oh, this pisses me off. This site, which is for people to send their pictures through, people who go out and purchase this little, they have like this little robotic 360-degree turn thing. But then you've got assholes from NASA showing up and dropping. Look at this bullshit. What a crock of, oh man, this pisses me off more than anything. Let me get back to showing you full screen here. And let's go to this one. Yeah. All right. Go. So, I mean, this is just such a joke. Get this shit off the site. What a joke. I mean, this deserves to be on Gigapan. Wait till you see some of the other images, and yet they think that this is worth showing. Okay, this is from a tree. Thanks a lot. Appreciate that. Appreciate your tree bark picture, NASA, but nobody cares. But I mean, this is just such ridiculous nonsense. It's just a washed out image from the Atacama Desert. And I mean, look at this. What is causing this haze? Dust storms? Well, then how is the eye? That's interesting. What is that? Huh. I don't know if you can see that. There's like a little something in the sky there. But I mean, this is just, it's ridiculous. What is causing this? Man, that's like somebody using Photoshop. Looks like editing. It's just such a joke. It's like, oh, there may have been water on Mars. Oh, you think so? I think that mud pretty much guarantees it. So, stop being idiots. This is just ridiculous. This is not on Mars. Why they even show up on this site? I'd be so pissed if I was the owner of the site. I'd say, get out of here. This is not for you. God, this is so terrible. Crap. Total unadulterated crap. Let's go back here. Let's find something. So, okay, here's an actual picture that belongs on the site. Not nonsense from fake planets. But again, look at this mountain range back here. Unbelievable. Look at that. That is freaking awesome. And so it just takes people measuring out these distances. It takes time. You have to go to Google Earth. You got to figure out exactly what you're looking at. Sometimes these are, they have the GPS coordinates in there. Something else NASA can't do to save their life is leave the EXIF data alone. But these are, this distance here, I'm sure is crazy. And usually these guys will say, okay, this is the Dead Sea Salt Shore in Israel. So it's just something fun to do. You can see this mountain back here, which is more proof of things don't go over any curvature. They simply get too far into this atmospheric haze that we can't see anymore. It's that simple. Let's go back. And so we can see, look at this picture. Excuse me. So this one, what is that? So yeah, it's just fun to find out what that is, where we're at. Where is this? South from Pretoria. And I've seen some far better images than this. And again, it's just crazy to me that what people believe. If you believe in the globe, then you believe that past this, that things start to go sideways. That they eventually you'd be sideways, and then eventually you'd be upside down. It's a crazy belief to jump to that conclusion. And even pictures like the ISS or hot air balloons or helium balloons. Think about what we're seeing. We're seeing the view of a person above the Earth. And that's all you would ever see. Even if the Earth's a ball, like they say, well, the ISS can never be underneath the Earth. There is no such thing as underneath the Earth. There's no such thing as on the side of the Earth. So they want their cake and want to eat it too. They pick and choose when they want to employ something. The ISS shows you images like from the side of the ball or from underneath the ball. How is that possible? Think about it. If you got up above the ball Earth, you would always be at the very top of the ball Earth. You can't go to the side of it. You can't start going over the curvature. You can't start going over the edge because it's always the same. You're always at the top. So it's just nonsense. And really, when you just look at this, you can just see that we're running out of the ability to see. And somebody might say, "Oh, this is a curve." Well, you can see where this land gets higher, and go to Google Earth and find out how high this land is, and you'll see that you just run out of the ability to see. Let's see if there's any other cool ones here. This is just like a beach. Finding out the distances between like the right and left arms here. This one's awesome. Look at that. This is the Netherlands. It's a little hazy. There's some much better ones, but some of these distances are just crazy. I've seen much better images. Let me see. I wanted to look at... There was one I saw the other day. Let me see if it'll come up. The other day I was looking and I found... let's see. California... did it say? I don't remember if it said the peak name. I just happened to be going through. That's awesome. That's awesome. I don't know if I can find it. Don't think that's real, but anyway. Wow, that's crazy. Where's that? San Francisco Bay Area. That one's pretty cool. Shoot, there's too many pages. So I did find the place that we did the test, which was crazy. I'd never seen that image before, but I can't remember how it described it. What did it call it? It was from... Damn, I'm trying to think of what... It didn't call it anything like the canal or anything, because it was a picture from the mountain next to it. I shouldn't have mentioned anything, because now I'm going to be stuck looking for it. 1 second. Is it this? Nope. I can't remember what it was called, what I was looking at. Like the valley? It may have been called the San Joaquin Valley. Let me see. I don't know how to spell Joaquin Valley. Jaquin. No, that's not right. How do you spell San Joaquin? I don't even know that. San Joaquin. I have no idea. San Joaquin. Get close to it. There it is. San Joaquin. Joaq. All right. Let me copy that. Put it back over here. Let's see if that's what it was called. Probably not even what they called it. Maybe they did. Let's see. Not that. Nope. 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 How many pages? Only 3 pages. Got to be one of these. But I just thought it was cool to see a long shot view of... Wow, that's unbelievable. Wait, is this it? No. No, where is this of, though? Eagle Rest Peak. I mean, some of this distance is unbelievable. Look at these mountains back here. Yeah, I mean, this is the kind of thing, if somebody's just ever got time, go through this site and just find out some of the distances that we're actually seeing, punch it into the calculator, and you're going to find out that... Where's that? A clear day? No. Anyway, there was one... San Joaquin Valley, is that what it said? California Honeybee, not that one. It's not that one. Nope. Shoot, I don't remember what it was called. Or I'd be able to find it. Sorry about that. It just had the was it Devil's Peak? Might be Devil's Peak. Let me try that. Devil's Peak. I think that's the name of the mountain. Devil's Peak. Is this? That's the same one we just looked at. Eagle Rest Peak. It's not that one. Wow. Sometimes I'm just shocked at some of these images. See these snow-covered mountains back here? Nope. Damn it. I can't remember the name of the mountain. I'm just going to go to Google Earth real quick and find this because it's going to bug me. Hate when I bring something up and then don't have it ready. But it's cool to see. Where is this? Okay, we're over here. I just need to remember what the name of that mountain range is. Yeah, this one. What is that? That's Clear Lake, but no, it was more this way. Clear Lake, Brushy Sky High. Oh, it was said Fremont Peak. Let me see if that works. Fremont Peak? Fremont. Ouch. Nope. I don't know the name of it then, I guess. Let's see here. I don't remember the name of it. Fremont Peak. What's this one? 360 Sample V Reservoir. That's up too high. I'm by Lake Tahoe. Yeah, it just had a really good view. You could actually see there was the 4-mile stretch that we did the test on, but then you could see the 7-mile stretch, the one we would like to do, but we can't because it's private property. I don't see it. God, I don't remember what the name of... Let me turn some of this stuff off. I can't see the screen. Where is this at? There, Sacramento. It could just say Sacramento. Discovery Bay, Antioch. What's the name of this little pond that it was by? There was like a little pond. Yeah, this thing. What is that? Schoolhouse, Big Island, Goat Island, Pope Valley, Hidden Valley Lake, Clear Lake. None of those ring a bell. Napa? Might have said Napa. Sacramento. Let me try that. And then if we can't find it, well, I'll show you some other time. Let's see. Was it Napa? Napa Valley. Could be Napa Valley. Let's try that. But again, check it out. Head over there, and you're going to see some distances that prove, at least in my opinion, that the ball is not possible. It just isn't, or it's much, much larger than they've told us. That would be the only other thing that. Let me see, Sacramento, because that would be the area it was showing. Let's see. No, where's that? Mount Diablo, view of, Devil's Peak, Mount Diablo, Pittsburgh. This doesn't look like it, but it might be Mount Diablo, since I said Devil's Peak. And 12 pages. Kidding me? No, we're not going to look through that many. Yeah, that's why I usually like to look at horizons, or you can find all kinds of fun things to search. But let me try Diablo one time and see if that's it. Nope. Diablo, Mount Diablo. The big valley of Central from Mount Diablo. This kind of looks like it, but it's not. I can tell. Maybe we can see it from here. Let's look. And some of these distances are crazy. You can actually see in the other image the Sierra Nevadas. You can see the snow-capped mountains of the Sierra Nevadas. And this is almost over by the coast of California. It's crazy. Crazy distances. This is not it. Not the one I was looking for, at least. And, wait, what's the difference between that one and this one? Nope, same thing. This one, nope. Awesome picture here. Not that one. 16 pages, jeez. I'll have to find it some other time, and it definitely looks the same as these, but you can clearly see the 7-mile stretch of river, and it's just cool to see the picture. Wow, is that a city? Oh, it'd be interesting to look at. Look at that. Unbelievable. Sorry, I'm in awe sometimes of this is San Francisco, if you didn't know that. Crazy. But here's something interesting. If you go to the Pontchartrain, did I spell that right? No, I did not. How do you spell that? Pontchartrain? Is that not right either? All right. I don't know how to spell anything tonight. Lake Pontchartrain. How am I spelling it wrong? Oh, that's why. I wasn't even close. All right. So let's go check this out. What? Pontchartrain. Gigapan. What did I do wrong here? Pontchartrain. Isn't that, it's called the Causeway, right? Is it Pontchartrain Causeway? Is that the name of it? Anybody know? I don't know. Let's see, that's Snowden Causeway. Maybe we can search by New Orleans and see if that's better. New Orleans. Just to show you the bridge that everybody thinks shows curvature. Let's see if we can find any good images. This one here might be interesting. So I'm just seeing the distances here. You can see these crazy, crazy distances. I don't see the bridge back here. Oh, there it is. Yeah, you can actually see it. I don't know if you guys can see it good. It's way back here. You can see it running along that whole stretch. Again, if if what Soundly was seeing was curvature, then from this view we should see it curving down. If it's so drastic, again, this is where the bridge actually lifts up. That was weird. Let's see if there's a better one than this. Let's see. This is that same view, but at least a much better day. Let's get out here. So we can see it running here. It's hard to see, but it is running back here. And you can see it heading off this way. There it is again. There's the little upper part that kind of goes up. But some of these distances are just crazy insane. So I think that there's lots to find on this site. Let's see this one. So this is the buildings there, I think, at the end, the parkway, which means that it's going to go, there you go. See it right here? So you can't see this because of the trees. Then you've got the causeway here. And let's see if it curves. All right, curve. Is it going to curve? Where's the curve? Where's the curve? Where's the curve? Nope, it just runs. There's the curve there because it lifts up, as you can clearly see. And the rest of the thing, it just runs straight. There's another lift. But we've got no curvature here. Stand back and observe this entire line. And this would be, you're talking about, if this distance is the entire bridge, I mean, you're looking at a huge distance there. And yet he's showing a view that you can only see 3 miles to the horizon, and he's saying that we can see curvature. Then 3 miles is probably from here to, here. So where's the curvature there? And plus this, add it to this, add it to that. So anyway, just wanted to point that out. See if there's one more good one. That one looks a little hazy. That one, it doesn't look like you can see much of the bridge. Let's see. I don't know where that is. Anyway, what is that? Okay. This one here, what are we seeing here? New Orleans downtown. So we'll pop out here and see what we can see. So you can see it running back there. And, straight as an arrow, straight as could be. There's no curvature. And the third person's perspective proves that all the time. They only want you looking from the person's perspective where things get smaller with distance. Because that helps them prove what they're trying to force, is that things curve away from you, but from that third person's perspective, it never curves. So we should be smart enough to recognize, well, the reason things appear to get smaller and appear to curve, if you want to call it that, from our perspective, is because we're taking only the viewer only his observation. We're not taking this side person, meaning if somebody stood here and looked off this way, they're going to see what it looks like this bridge curving down away from them. But if this person standing here would clearly see no. Just like if a boat left here and started going this way, well, within 3 miles, the person standing here would lose the boat over the so-called curvature. So the boat would go over the curvature. And if a boat left over here doing the same thing, 3 miles away would go over the curvature. But from this perspective, we would clearly see the boat going the whole way. So we would say, no, guys, it's not going over any curvature. It's straight and level and narrow, or, level all the way across. That should be all it takes. But of course, things aren't quite so easy. Okay, so that was basically all I wanted to talk about with GigaPan. Check it out. Again, that's just gigapan.com. And if you get a chance to leave any nasty comments to the NASA posters, I always think that's a good expenditure of time. So that one's done. Okay, so we were talking, we got that done, told you about that. This is just some images from that company, White Desert, and we're done with that one. So the other thing I wanted to show, we showed this, we're all good there. Showed you the $80,000 per person, we're done that. Last thing I wanted to show too here, I don't know if people have seen this site, I just found it the other day. I think it's better than SunCalc and day and time and date. It's just called sunearthtools.com. And the cool thing is here, you can do a couple different things. For instance, you can bring up, should be a little chart here. There it is. You can bring up like a sun path, and you'll get the same thing that you get from, the only thing I don't like is it doesn't let me use my scroll on the mouse. So it'll show you your sun path, but then also you can see sun rays. So it shows the rays, and this is showing the rays per each hour. So for instance, at noon, this is where the rays are coming at 6, 2, 3, 4, 5. And then you can also get shadow. So you can see where the shadow would be. So we're right here off the coast of Mexico. The sun, what day are we on? So this is showing today, 1/7. And when the sun rises, the very first thing that's going to happen at 7 a.m. is you're going to get this shadow. And then at 8 a.m., 9, 10, 11, 12, 13, 14, 15, 16, all the way to 5 p.m. And you get this. So there's some interesting things that take place here. And you can just move your little guy around here. You know, if you go down to the south and you start looking at where some of these shadows are versus the north, when you find the same latitude, if you will, and then, you know, compare them, you're going to see some interesting stuff. Here, this is showing that right now, January, let's put this over in Argentina. Get on some land. Okay, so it's oops, I clicked here. There we go. So it's showing that, you know, 8 a.m. the sun's going to shine, and you're getting this shadow here. Now, then, so the sun's up here, which is crazy with 1/7, 12/21. That's interesting. So at 8, shadow goes this way, 9, 10, 11, 12, then it comes this way, 13, 14, 15, 16, 18, 19, 20. Yeah, so basically this is why when they talk about the sun rising south of east, it's rising from here, going around to here. Again, that's a perspective issue. It's not actually rising south of east, but I've talked about that in some other videos. But maybe I'll put together a good video using this, and you can get path and rays, which is showing you the sun rays different times. So anyway, I just thought it was more comprehensive than the other two sites. You can also, change your time and date to whatever, and put in your coordinates. So pretty cool. And we talked about that. Did this one. Okay. And we'll go back to this. So just wanted to finish off with this, talking about the 24-hour sun. And let's bring this up. Overlay. Nope. This one. All right. And here we go. Okay, so we were talking about this, and I wanted to show you some of the moon's movement. Where is the 2017-12 large? This one. So this is the a monthly view, and this is 12/2/2017. It's going to go through the whole month of December. But just watching some things like the moon there going by. Here comes the moon again. A little bit of issue. Usually, sometimes it will get iced over that I've seen. There, see, now it's melting. Come on. There we go. And some of the better views, obviously, are the day ones, not the night. But there goes the moon around. And you can clearly see that the moon is going around you. It's not even hard to figure out. There goes the moon around. So it's going from left to right and then circling behind our head. And that proves that the sun circles and the moon. They all circle. So let's go to a 2016 12. Nope. Let me find 2017 12. Nope. Trying to find a daytime one. 1 second. Let me go back to this site. Let's go June, the whole month, and this one, June, large. Okay, that's downloading. Give me 1 second on that one. So, yeah, the only sucky thing is every time you click one, it downloads it. It doesn't let you like watch it on the site. Let's see, this is 2016 12, so the whole month of December here. And this is 2017 623. I think we looked at that one. And we looked at 622, 613, 2016 317. What's this one? And this is a small. I was just trying to see how bad the quality is. This is a small quality. Is terrible. Get the large one. And let's see if that's downloaded yet. And let's see. Downloads. 2016. What month was I in? Or what year? 1 second. What year is this? 2015. Okay, 2015 6 large. This one. All right. And let me find it in here. This one here. Hello. Okay, so this is 2015 in June. And so we're getting, again, this is from Norway. And you're getting this sun doing its 360. And again, it's circling. And that's kind of the point of the video, is that people are saying that the sun doesn't circle. You've heard Darren say that, Nesbitt. You've heard tons of people, for some reason, locked into this belief that the sun doesn't circle, and I've yet to hear them explain how it is that people in Norway or these other areas are seeing. And Bob has stated that he's seen it. I've talked to a subscriber that lives in Norway, who it's a fact of life there that they've got to deal with. So we're here at 614. And again, we called I called the lady at the hotel, and I encouraged you guys to do that and let me know what your results are. But I have a hard time thinking that you're going to call somebody there who is going to say, no, we don't have it. And again, you can't call Antarctica. You can't call and talk to somebody and ask them at a hotel if they see the sun. Most of the people that are down there are military or going to be compromised in some way, but you can feel comfortable that when you call some random business in Norway, that they're not going to have any reason to lie to you, unless all calls to Norway get redirected or something. Who knows? So anyway, that's kind of the basic point. I was going to look at some of Jake's video, but it's just him doing a funny voice, talking about the problems with the glass dome, saying we don't live inside glass, which nobody's saying we live inside glass. Sometimes you need to show, you need to model things the best that you can. Again, none of us have a bunch of money. We can't go out and spend money like these scientists do to be able to model these things in a lab. We're just guys on YouTube. That's it. So if you expect more than a half dome of glass to show you how things can work, doesn't mean that is the way it works. But the point of showing that is because the AE map has not been debunked. To go around calling people Gleasontards, just so that Jake can never admit now if he's wrong. That's the problem when you've made that step. That's why I've never said things like Globetards. I don't want to say that because if I'm ever shown to be incorrect, I don't want to have to worry about, well, geez, I called a bunch of people names. I mean, my opinion. I think that the globe is a deception, and I think that it is a crazy belief. Those are things that I have no problem. If somebody ever shows me proof that we're on a spinning rock in space, then I'll be happy to admit that and stop going down the wrong road. But all my research is showing something different. But when you've gone to the point of calling people Gleasontards, making fun of people for the wrong map and the globe number 2, and BOB is a piece of garbage, and Kyrie Irving is compromised. Once you've gone that route, then hopefully you guys recognize that he has to go down burning with the ship. That's his only choice. So expect that. That's what's coming, is a complete implosion. that's he set himself up for that. That's the way it goes. But the only thing you can do is learn from it. That's not probably the best method. Better method would have been bringing some of this stuff to our attention and saying, hey, how can we work this out? What are we working on? What have we been doing? That's why when he asked me, I told him, don't debunk it yet. We don't have a sufficient answer to where you can do a video saying, Cool Hard Logic said this, and this is the explanation for it. We weren't at a point that we could do that yet. Now I would feel more comfortable in doing that. But, Jake went about his own self in determining that he thought that is a deception, that the map has been placed there and that we're all lying and I'm an agent and, the whole 10 yards. One thing, talking about starting to lose it a little bit. Which one are you looking at? Are you looking at my... Nope. Browser. Yes, this one. There we go. Just to kind of bring up losing it, if you go to... I don't know if you guys saw this, but this is the kind of stuff where I'm like, all right, we can't... This kind of nonsense is just going nowhere. Flat Earth Asshole has a recent video where he says he's not saying that it is, but he's bringing into question whether or not this is Neil deGrasse Tyson in disguise. Give me a break. This is not Neil deGrasse Tyson in a disguise. Period. End of story. There's no reason to make a video questioning whether or not this is Neil deGrasse Tyson. You can't put pictures of people on top of other pictures. We're all human beings. You're going to be able to do that with anybody. It's just a joke. This is when somebody's lost it. And I've got text from Jake saying he has nothing more to make videos about. He doesn't know what he's going to do. He doesn't make enough with the videos. And I must be fake because I'm able to do videos for a living, which is not true. And he just assumes that. Doesn't know that I have a bookstore. Doesn't know that we travel all over the place to auctions, to buy books, to buy antiques. I can't just make enough money doing YouTube videos about flat Earth to do only that. It's just crazy. And other people that might be able to, they have their own particular whatever reasons. If Patricia had money from a death in the family or whatever, I don't know. It's none of my business. But it certainly is not reason to say, well, this person's not working, so therefore they must be compromised. That's just not fair to say. It's just not true. So it just baffles me when you've gone that route. And again, expect him to go down with the ship. He has to take this side now to basically call people Gleasontards, which is ridiculous. That is... Stop it. That is going the direction of Cool Hard Logic. That is using ad hominem attacks. That's exactly what flat earthers are sick of. Is no evidence, but just ad hominem attack after, and that's what he's doing. That's what these videos are about. So let's make fun of people's voices and call them rednecks or whatever. And this is a great job. We shouldn't be making fun of people who are doing experiments like this. Nobody is saying this is the Earth. Nobody's saying that there's a glass dome on top of it. Nobody's saying that there's a half dome on top of it. Nobody's saying that. It's just not being said. So to then take, it's a complete and total straw man. It's a straw man argument when you've taken somebody's video who's just saying, hey, this is interesting. Look at what's happening here. We're able to get this light the outer edges. Then it inspires people. It inspires people to say, you know what, I have an idea. I didn't think about that. This needs to be on a larger scale. We need to get 2 bowls and put water in between them. There's so many ideas that people need to see, and these kind of videos stir that up in people. And when you've got somebody like Jake making fun of people because he says, we don't live in a glass, how would you breathe? That's a straw man argument. Did this video come out and say we live inside of a glass dome and we breathe the glass that's in it? No, of course not. Because nobody's that dumb. Well, obviously somebody is because they think that's what was being said. Or I've heard him before say, we don't live in a coffee cup. Yeah, we certainly don't live in a coffee cup. Look at, this is solid glass. Yeah, no shit. What did he say there?
Solid glass paperweight. There is no weather patterns. The sun and the moon do not go around in a circle inside the solid glass paperweight.
That's the kind of stuff we're dealing with now, and that's why I used to have some respect for Jake. All gone, completely gone. When you've gone that route, that we don't live inside of a solid glass paperweight. Yeah, genius. You think that's the kind of videos we need to be doing? We don't have time for it. It's just ridiculous. Putting other people down who are actually trying to show evidence, that are trying to show research, that are trying to show different ideas, stir the imagination. That's why I showed my glass half dome, because I was trying to get people to see that there's so many things. And for me, it started with my wife telling me, could the earth be flat? And me saying, no, how do planes go around it? When I said that, I meant it. Like, how could planes go around the flat earth, you dummy? Because my brain couldn't get past the idea that there's no way planes can go around a flat earth. Then when you see that Gleason map or the AE map, it was like a light bulb. Like, holy shit, planes can go around a flat earth. So that's the kind of breakthrough sometimes people need, that we're just locked into a certain belief system. That's obvious. And, again, we talked about it yesterday. I mean, there's people who will swear up and down that Mars is a place you can go to. Just think about that. Just think about the fact that none of us have ever been to Mars. No human's ever been to Mars, yet there's people on this earth that will swear to you that there is a rock planet Mars in the sky that you can go to. Well, with what evidence? This is the problem. We have accepted words of men to be our reality. And in my opinion, your senses dictate your reality and not what people tell you. That's the biggest mistake you can make. In fact, and I don't like to harp on Christianity or anything like that, but if you ask me, what's the point of life? What's the point of the universe? To me, it comes down to, did you trust men? Did you take on faith what men tell you? Because that's got to be the biggest mistake that you can make. I mean, there's no reason to take men's word for anything. And that's what we've all done. We've just simply taken the words that they've said is true. And because there's a group of them that say it's true, then we think it's true. And because some of them have credentials, well, yeah, if you're teaching a lie and you put it in books and then you tell those people by reading these books and becoming proficient in the information that's contained, you become a doctorate. You get your PhD. Well, that would be the way you would structure the world when you're teaching a lie. You would structure it that way so that the smart people are the ones that are smart in the lie. So yeah, is Neil deGrasse Tyson smart about astrophysics? I'm sure he is. Sure, he knows tons more than me. It doesn't make it true. It just, he can know a lot about the lie. It simply doesn't make it true. What else does he have to say here?
Yet we are trying to compare this with a dome that would be sitting over the top of the flat Earth, with oceans and weather patterns and air inside.
Yeah, and if he listened to any video besides Cool Hard Logic, he would understand that the way the atmosphere works is a lens. It's the same as a glass thing. Granted, there's not glass in here. We're not breathing glass. We're breathing air. On the size dimensions of the Earth, it works the same. It is the same. You're getting a lens view. You're getting the apparent sun. We see all the atmospheric effects. Think about a rainbow. A rainbow is an atmospheric effect. In my opinion, it has something to do with the shape of the atmosphere. Let's continue.
How can we compare something made of solid glass that does not have an atmosphere
The solid glass is the atmosphere.
with something that would be considered a glass shell with an atmosphere inside? It seems like we're comparing apples to oranges here and acting as if they're supposed to be the same thing when they are clearly not.
Clearly not.
Furthermore, the video maker who performed this childlike demonstration is purposefully trying to be deceitful by using a solid glass paperweight and saying that that is comparable to an atmosphere.
Too funny. He's saying, I don't know if you guys can hear when I play YouTube videos or not, but it's just nonsense. It's just not the way, it's a straw man argument. I don't know what else to call it. That's what it is when you've taken, yeah, I did see the end of this video. This is classic. He goes on saying that that Google is,
Earth.
listen here, this is hilarious. I don't know if you can hear it actually.
Look at this. Flat Earth map set, Gleason. So, they're running Flat Earth map ads on my video now. What the fuck?
So he says they're running flat earth map ads on his video. That's the way advertising works. See, the people who own the site where they sell maps pays money to Google to get onto videos that mention AE map, Gleason map, flat earth. That's called advertising. It's like, what is he saying? That this is a ploy by Google? What is, I mean, of course it is.
Flat Earth map set, Gleason standard,
Yeah.
and square stationary
Smart.
Earth,
Yeah, smart advertising.
$29.95.
Yep.
They're
Makes
running
sense.
this fucking ad on my video.
Of course they would. What would they run it on? Videos about, the globe? Doesn't make any sense. Whoever bought the ad obviously correctly identified keywords that would show up on your video.
What the fuck?
Unbelievable.
Ads by Google.
Yep, that's what they do.
Get both Flat Earth man. I've never seen them run an ad to buy Flat Earth maps before on any video. And here I am debunking this bullshit map. You click on the ad, and
Yeah.
it wants you to pay $30 for what looks like a poster.
Yeah, that's what the people are charging.
Wow.
Don't pay for it if you don't want it.
Holy shit. Seriously?
Seriously. That's the way that
Look
advertising
at that,
works.
man.
Yep.
Running fucking Gleason map ads
Yep.
on my debunking
Yep.
of the Gleason map.
Can bet you put Gleason and stuff in the tags.
hell? Man, that's some weird shit right there.
Yeah, that is weird. So anyway, and you notice here it says this video is dedicated to Jeran and Fat Ass Bob. That's nice. Suck it, Gleason tards. Suck it. So when you've said this, you can no longer backstep. You can no longer admit that you were wrong. You have to go down burning with the ship. So watch Jake if you want, because over the next little while, you will see somebody tumble into crazy nonsense that everybody will be against him and that he's the only real person. I mean, it's the only way he can go. He can't step back and say, you know what, you guys are right. I didn't realize that when the guy's showing the glass half dome, that it's basically acting as our atmosphere acts, and we can show ways that it does. I didn't realize that. I didn't realize that because of the way that the dome is shaped, or because of the way the atmosphere effect is, that we might see the sun rise south of east when it's actually rising to the east. He can't do that. It's sad because I like Jake a lot. Some of the videos that he did early on, I remember at one point, who was it? John B. Wells did a video slamming Flat Earth. And I remember David Weiss texting me and saying something to the effect of, we need to Flat Earth asshole him. And sure enough, within 2 days, and I think somebody just mentioned it to Flat Earth asshole, like, hey, this guy's going after Flat Earth, and here came Flat Earth asshole with a fantastic video destroying John B. Wells. That's how we need to work together as a team. That it worked great. It was like, oh, Jake's got a great position here as the Flat Earth asshole. But what happens when you've gone this far now? You can't come back. I mean, there's no coming back from where he went because you've called people Gleason tards. I mean, just that alone. Be careful with your words. They may come back to bite you, and I think that's the case here. So anyway, guys, it's been fun. I went too longer than I wanted to go. But wanted to show that the sun does circle, the moon does circle. Also call your random number in Norway or up further north and ask them if there's a 24-hour sun, what days it runs. She told us April through 26th of August or whatever she said. And so if you call somebody else, see if we get the same answer. Many of you probably know people that work or live there. All you have to do is ask them or somebody who's been to the northern part of Alaska, and you can just really figure it out on your own by simply seeing where the sun is for you. Maybe find a webcam north of you, and you will see that the sun will drop. And if you go north of that, then the sun will fall even further. And it kind of goes back to what I drew at the beginning with the sine wave of the sun. So I just wanted to point that out. The sun does circle. Anybody who says it doesn't, I would love to see what their proof or evidence of that is. It circles. I mean, I don't know what else you need to know besides that. So I think that that's it that I can think of. Check out Globebusters tomorrow morning. That is at noon Pacific. We're coming back from a 2-week break, so should be a good show. And besides that, as always, you can support me if you'd like, either through the paypal.me/Jeran or through patreon.com/Jeranism. And I hope to be coming back soon and taking more calls. People seem to like that. However, I do admit that I was completely spending way too much time on each call. So a couple people emailed me with some ideas of how to move that along quicker. They would have rather I got to a bunch more calls, and I agree. So, always changing, always adjusting to try and make it better for you guys, and at the same time beneficial to everyone listening and to myself. Like I said, I love to be challenged on these things, but challenged correctly, not by saying that we are claiming we live inside of a glass paperweight. Nobody is claiming that. So be kind, don't lie, and open your mind and find your own truth. Till next time, guys, this has been Jeranism. Peace. I mean, it's obvious why, but this site is weather.cs.uit.no. It's from the Arctic University of Norway. This is pretty incredible. They have, you can go to any year, previous year, go back even further. And these are all daily time lapses for every single day of that year. And, this is something they don't have in the South. I'm sure people have seen before. Do I have that up? Is it this one? Yeah. So this is the South Pole webcam page. Much different. The fact that, number one, it starts with the live cameras currently down. You can also see time-lapse movies from the camera. So we'll just jump over there real quick. Here's a time-lapse. Takes a little while for it to... Oh, that was quick. So if you go to, for instance, this is set January through March 2016, and we press play on this. So as I pointed out before, if we can just watch this time here and see that the camera skips. So we'll watch it 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 6, 7, 8, 9, 10, 11. So when we're looking for evidence that the sun circles in Antarctica, you would expect to find 24-hour time lapses. It makes no sense why you would have, half a day time lapse. And if anybody remembers, I actually emailed these guys and tried to talk to them about it. And they just made no sense. They said there's not enough bandwidth to do a full day's time. So, but they have enough to do half day. So I was telling him, well, wouldn't it make more sense if you had 1 month of a complete time lapse than 3 months of half day? But again, they said, it's not in our mission statement to provide those things. So, but there's a definite problem here when you look at the sun going 13, 14, 15, 16, 5, 6, 7, 8. So we never get to see any of these, and it's the same for all these. So you can go to September to December 2012, bring that up. Again, it takes a little while usually. And we'll show you here that it's the same thing. It cuts out dates and times, or not dates, it cuts out times, and only shows you about half the day. And if we're trying to get proof of a circling sun, that's not going to help us, as we both agree that the sun goes by half the day. So that doesn't help much at all. Is this going to come up or what? Okay. But this is much different. Like I said, these are, 3-month-long time lapses that are skipping days, and you're not going to find much better. Here we go. Let's play with this one. So this is September to December 2012, and you might not be able to see it up here, but again, it's 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 8, 9, 10, 11, 22, 23, 1, 2, 3. So again, it's completely skipping, over the hours. There's not one complete day in any of these time lapses, which is just a joke. It's like a slap in the face. So that makes no sense to me. Why would we have not one day complete? But on that site that I was just telling you about, again, just to give that web address, it's weather.cs.uit.no. And so you can go to any of these. So let's go to, let's go to 2017. Maybe we go to June 21st. So you go June 21st, and you can then download you just press the L, and it tells you down here exactly what you are getting. The daily videos, small, medium, large, monthly videos, small, medium, large. So for the monthly, you just go down here and you can pull up. So we'll also pull up like a December monthly. So I'm going to press large on that one, let that download. So once you have these, I'm going to download another one just to have a few. Let's do, we'll go to a previous year, 2015, and maybe a full month from June. And large. Okay, so those are all downloading, and we'll show you those. So very cool site that they have all these time lapses in complete form. There's no time skipping, which I will show you here in a second. Let me get that going. And let's see here, where are we at? Default. And, okay. Is this the right one? 2009, 6/9, 2017, 6/21. This one. Okay. And let me bring that up for you to see. And that one. And OBS. Yep. Okay. Making sure you can see what I see. There it is. Okay. So this is the webcam footage here. And we'll go ahead and press play on this one. So this, you can see the date down here, 2017, 6/21, which would have been, the height of the northern summer. We should get a 24-hour sun. And it looks, all the webcams are taken from this exact spot, at least the ones I've seen. I've only gone back to 2009. It's hard to find days where you can actually see the sun circling, but you will see plenty of them. It's just not every day can you actually see it. You have to kind of find the right day. And let's see here. So I wanted to also show, okay, what day did that go to? 2017, 6/21. Okay, here's 2017, 6/22. Then we got one after that, 6/23. And we can actually see the sun. Usually, it's pretty high up there. It goes right here if you can see that. There's the sun there. And what you get, and especially on the sunny days when you find the good days, I downloaded 20 of these earlier today. Here's a good sun. You can watch these shadows, come around. You actually see the sun make that full turn. Let's go to 6/23. So, we have something here which is the sun in the north doing a 360-degree turn. Here's the sun here. About your body. You have to do a 360 turn if you're going to watch it. I did another thing today, and I just did it for myself, but also so that anybody can do this if they want. What I did was, hopefully I can find it here. What I did was I just randomly went to, and I'll show you how I did it. If you go to Google Earth, I just randomly went down to Norway, which is, I'm sorry, I didn't go to Norway. I went to Svalbard. And when you go down here, you can find that there's tons of hotels, little eateries, restaurants, car mechanics, tons of businesses. So I said, well, we'll just call businesses and ask them if there's a 24-hour sun. I don't think that it's not like it's directed to the military and they're trying to protect. So I did call, and I have that recorded. Let me just show you that one phone call, just so anybody can do that. It's not a matter of, oh, I did it, so it's proven. Take this, go to any of these locations, call them and ask them a question. Let me just do a circle, be easier. Let's do it that way. Okay, and orange, and off. All right, so if we're getting this kind of path here on the outside, and where does the tropic go? Yeah, there. If you're getting this path, well, then where's the only place that somebody's going to see the sun if they're here? Well, the only place that they're close enough to see it is going to be, in this region here. So they're only going to see the sun rise here, set here, and they don't see it this entire time out here. So that is pretty much what we see from the webcam. Many people have seen pictures of or video of the 24-hour sun where it's kind of doing the one of these in the sky, which is what it would do if you weren't close and you were watching it. So, for instance, when they get close to their summer, which we'll do this here, which is this inner track, maybe there-ish. It's a little bit more out there. So the same thing here is they're going to see the sun for the entire time. Now, they're a little bit outside the circle, like I said. So, again, they're going to lose the sun probably here. They're going to see it rise, come across, and set. And from their view, they're going to see it, since it's rising, it's going to be low in the sky, and then it's going to come up as it hits noon, which is going to be here. So it's going to be at the highest point for them there, and then it's going to go back down and head around this way. Then it's going to set and then come back up with a rise. So it just makes sense on this map. I don't think there's anywhere near any enough problems that we would need to disgrace it. Maybe we can check out in a second Flat Earth Asshole's video to where he's decided to make fun of the glass half dome placed over the azimuthal equidistant map by making jokes about, well, if you live in this glass dome, how do you breathe? And for anybody that dense, how can you help them? Nobody is saying that you live inside of a glass dome. As we've said hundreds of times, the atmosphere of the Earth acts as a lens. So since we can't manufacture a little tiny atmosphere to put on paper to show you on a video, then the glass magnifier works much like a lens. It is a lens. It's a magnifying lens. So what people are showing is how light reacts in that dome. Here's the weird thing about the dome of the Earth, and this is going to sound crazy. I know that, but this is the way that I'm seeing it. At least my research is showing me. The dome, call it a dome if you want, call it an atmospheric effect, whatever, is actually situated that it's the lowest at the poles, okay, and the highest at the equator. So the dome is going to be, and when I say dome, I don't mean like a glass dome, but I'm just talking about the atmosphere, is going to be something like this. But it then has to go like this. And, obviously that would be everywhere. There's going to be, it's basically like a donut with a dent in the middle. And so this acts as its own dome piece here. And the reason you can go off that is the stratospheric heights are the lowest at the poles, highest at the equator.
Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff.
We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage. Mirage.
What's going on, everyone? It's Jeran back with another live video for you this evening. Promise it will be far shorter than last night. Just want to show a few things, and that's about it for today. Sorry this started late. I was planning on 7:30, not 7. I also changed the title kind of last minute because I was going to make a claim, and I'm always the one saying don't make claims. But I'm going to hold off on it until I have a little bit more time to investigate it fully, and then I'm going to issue it as a challenge. So if you saw the title, you probably know what the challenge is anyway. But I'm going to look into it just a little bit more. Thank you for joining me this evening. Hello to everyone in the chat. Nice that you could be here. Sorry I'm late again. And also I saw a comment, just wanted to clear it up. I saw somebody say, why do you do the minute and a half at the beginning? And the reason why is because people get an alert when I go live, and I've had people say, hey, it sucks because I get an alert when you go live, but by the time I get there, it's already started. So I just figured by doing that, gives people time to get there if they want. That is that. So what I want to start out with is something I talked about yesterday, and I just wanted to kind of clear it up, and that is in discussion about the circling sun. Now, some people have said that it's been debunked, and so I want to bring up some proofs that it has not been. Let's see here. So you should be looking at my browser now. So I found this really cool site. Let me show you where it is here. Okay. So, and it shouldn't shock you about the 24-hour sun. They're going to tell you. So let me show you that. Okay. And here we go. Let me get that call up for you. It's a short call. It's like a minute. But that's the kind of thing that I think people can prove. The problem is you can't call somebody in Antarctica. Let me bring this one up. And I don't know where my video went. 1 second. Default. I'm going to have to load it here because I don't have it. Load this one. Okay. Now it's going to come up. So hopefully you can hear this. Let me turn it up. Hello. Do you speak English a little bit?
Yeah.
Okay. Quick question for you. My buddy and I are staying at the hotel in June of this coming, 2018, and we had a bit of a argument. Or I was telling him that we'll be able to see the 24-hour sun, and he said that we will not. Will we be able to see it in June?
Yes, you will. It's here from April until end of 26th of August. I think the sun goes down.
Okay, so that entire time, if we're going June, I think we're there the 20th through the 24th, then we'll see it from there, right?
Definitely.
Okay, thank you very much.
Definitely.
Appreciate it.
No problem.
Bye-bye.
Bye.
So hopefully you guys heard that. Just as, you could do that yourself. Just call anybody randomly, and they're not going to try and lie. They're going to tell you the truth. She was obviously pointing out that from April through the 26th of August, and if you live there, you know the exact dates, that the sun doesn't set from April through the 26th of August. If that is true, then anyone saying that they have debunked the circling sun is out of their mind. There's nothing left to say. How have you debunked the circling sun when it clearly circles? If you stand, and I'll just show you a little example so we know what we're talking about here. Again, I'm not saying that the AE map is the map of the Earth. I'm saying that there's no reason to treat it as people have, like it's some sort of, you got to get rid of it. It's a Frisbee map. Well, if that's how you think of the Earth, then that's fine. Then, maybe you can get rid of it. But to then start putting threats out and saying, if anybody has this map or if anybody does, it's just ridiculous. We're researching. Nobody has all the answers. It's going to take a while. So this here image, just to kind of show you what we're seeing from Svalbard, which is, up here. Oops, what happened? There we go. So Svalbard up here. So, they're seeing on the circling sun, they're standing here and they're having to twist. They're having to turn 360 degrees around to watch the sun. So I don't get how anybody is saying that they have debunked the circling sun when clearly it circles. The moon does as well. I'll show you that here shortly also. And then if you wanted to see, like from the webcam that we're using, that webcam is from Norway. So it's a little bit more, it's a little bit more here. And it's kind of outside the circle. So there's going to be no day that is 24 hours of darkness. What they're going to see, and again, it works perfectly with this map, which is why I'm kind of bringing it up. If you've got something going on the Tropic of Capricorn, if the sun is going in that path, so, we're going to be doing it here. That's terrible. Wow, that's a bad circle.